Okay, I'm not going to answer your questions directly. I'm going to let you figure out after I go over the theorem that allows you to answer your question. And the theorem that we're going to prove is that if a point P lies in the perpendicular bisector of a line segment with endpoints A and B, then that point is equidistant from the endpoints of the line segment. That is, AP equals BP. It doesn't matter where P is on this line. As long as this is the perpendicular bisector, that point will be the same distance from A as it is from B. The segment AB does not have to be horizontal. It can be in any direction. But the definition of a perpendicular bisector is that it passes through the midpoint of the segment and it's perpendicular to it, forms a right angle. So we can actually use that information to prove that these two triangles, one on the right and two on the left, are congruent. Because PM is equal to itself by the reflexive property. These right angles are congruent. All right angles are congruent. And AM is equal to MB, definition of midpoint. So these two triangles, 1 and 2, are congruent by side, angle, side. And that means once the triangles are congruent, corresponding parts of congruent triangles have the same measure. So this side must equal this side. Now the demo that I'm about to give you on Desmos has the segment as a horizontal line segment, AB, but focus on these distances from AB to AP. I've created this red line as the perpendicular bisector of AB, that is, it passes through the midpoint of AB and it's perpendicular to it. Vertical line is perpendicular to a horizontal line. And as I move P anywhere on that perpendicular bisector, those distances remain the same, even if I'm exactly on the midpoint. Distances are the same. And I can change the location of A and B. Doesn't matter. L is, this red line is still the perpendicular bisector. Therefore, it's equidistant from the endpoints of the line segment. Okay, so hope that gives you some idea how to answer your question. If you have any questions about this, post a comment. There you go.